Hello, everyone, and welcome to another episode of Demo to Production. In this podcast, we will discuss what happens after a technology move beyond a local demo and enters a real production environment. Today, we're discussing an important change in the Model Context Protocol or MCP. The move from older HTTP plus SSE transport architecture to the streamable HTTP. But many people first time experience MCP locally and they create an MCP server connected to the client, expose a few tools, and everything appears work correctly. Now, but the real challenge begins when the same server is deployed into a production. The server may be placed behind a load balancer. For example, it may run across multiple Kubernetes pods. It may need a support several users at the same time. It may also need to survive uh, network interruptions, session expiry, retries, maybe authentication and infra and anything you can imagine in your production environment. At the point, MCP server may begin failing in unexpected ways. One request work while the next request fail. And the client appears connected, but the server does not even return a response. This is kind of the general behavior we see in every technology. So MCP going to face the same. The logs may not, suddenly explain the problem. It may cause the issue is not the AI model, maybe the MCP tool or the application logic. That's a debatable. But the problem may come from the transport architecture, session handling, and the way different requests are routed between server interfaces or the instances. The older remote MCP transport use separate endpoints in the communication, and the one endpoint established a long running SEC connections while another endpoint received message from the client. Now, that seems complicated, but I'm sure we have a guest who will simplify everything for us. So, Streamable HTTP was introduced to simplify this architecture. However, the change is sometimes misunderstood. Some people say the SSE has never been removed or depreciated completely. Other believes that changing the endpoint automatically solve every scaling and session problem. Today, we will understand what actually changed, why the older architecture created production changes, and what developers still need to consider when building remote MCP servers. To help us understand the topic, we have Animesh Pathak with us. And Animesh is a developer relation engineer at Harness, where he works around database, DevOps, API, testing MCP, I would say extensive testing, and the open source technologies. He also have been actively exploring how MCP servers behave in the real environment and what changes when an implementation moves from a local machine to the production system. The topic for today is very interesting, very depth in technology, and I'm sure you search everywhere, but you will not find easily over any platform where things been explored how MCP works. Understanding that failure lead scenarios. So an MCP servers worked correctly in a local environment, but started failing after it was deployed behind the load balancer. Understanding this failure led Animesh deeper into the MCP transport architecture we've been discussing about it and trans the transition from the older HTTP plus SCC model to streamable HTTP. So I know a lot I've been explaining. So I will welcome Animesh, who is going to simplify us everything here. So Animesh, welcome.
Thanks, Rajan. And thanks for a great introduction. Hi, everyone. Just to recap, I am currently working as a DevRel Relations Engineer at Harness, specifically for database DevOps and other developer tooling, including Harness AI, MCP servers, and testing those. Um, and yes, on the architecture front, this is something very important that we should first discuss before we move to the slides and the conversation. Um, First of all, yes, SSE isn't deprecated. It has just evolved. Um, Previously, it was used to be HTTP plus SSE. Now it's just streamable HTTP with even streaming inbuilt. Um, and when we talk about transports, we tend to discuss generally while we are building an AI app, right? So a common question that I have been looking across the community forums, whether it's a Reddit, over Stack Overflow, or even in conferences while talking to the people, I'm building an AI app. Do I need a MCP server? The answer is no. You only need MCP server when your AI application needs to interact with external systems in more simplified way, especially if you want those integrations to work across your other tech stacks or AI clients, right? Not always, because if you're building a simple chatbot, we already have more than capable LLMs, open models, which can work those. You can work with your internal APIs, transition further, maybe calling direct REST APIs of those LLMs. For example, how we use ChatGPT, right? So ChatGPT have codecs and it have plugins. Those plugins somehow would be calling their own internal data or APIs. Your backend would return the results, and that's how you see the conversation in your chat window. Same with the Claude, Gemini, and Codex. If you are just having a conversation, so those do not require that we build our own MCP server to do this and that. It's a simple. But if I talk about you have a system in place that you are upgrading, which which needs to talk about with many different tools or the services, data sources, context graph, knowledge graph, right? Then MC becomes valuable because MCP have those capabilities to integrate with all of those and serve as its own open source, or we generally say knowledge graph. Then it's become then it becomes very important for you. For example, if I am um, if you're building or I am building an DevOps AI agent, right? I need the access to read across the issues that I have or the repositories that I have. For example, I would be looking at my code repositories. I may have five. On those five I would have maybe multiple issues, discussions, PR going on, and the services I need to also deploy in the Kubernetes to check whether the build releases are working fine or not, and then send me an alert, whether on a Slack, Discord, or email integrations, right? So those kind of architecture or tech architecture generally needs an MCP server. But if it's just going to the GitHub, reading the issues or summarizing a issue, rather than MCP, your AI agent, Copilot, or LLM can do very great work because that is what it has been built for. Now, a second question comes most properly is without MCP server, wouldn't every AI framework would need its own custom integration layer? Not always. For example, if tomorrow, right now, Claude is doing great work with Fable 5, Opus 4.8, and recently released Sonnet 4.5, right? But whereas a ChatGPT have also evolved from Codex app, it moved from ChatGPT apps to the Codex app. So maybe tomorrow Cursor brings up something new, an IDE. Then should I don't want to rebuild those integrations again. Again, in those scenario, then MCP would be helpful because it becomes platform agnostic. I have my capabilities inbuilt in my server, MCP server, and I am using those compatible like, so I'm using those compatible client with any compatible clients, whether it's a um, Cloud Desktop, Cloud Code, Coworker, Cursor, or even JetBrains or Studio Code. So I think this is very important that MCP is just a USB-C type for AI rather than build on top of as a whole charging model system. We can connect with each other, but that's about it. Um, Now, when I mentioned about having a MCP and AI framework, uh, LLM chats or APIs, right? There's another misconception which I would say have been in a developer's mind for a very long time. it was with me as well. MCP server will be replacing my API servers, and no. The answer simple is no. Your API would remain exactly as they are, uh, but it would be simply sit on, like your MCP server would simply sit on top of those APIs. So, for example, if we treat MCP as a USB-C type, right? Then the APIs are adapters. You can just use them together. It doesn't have to be. What would you do with a simple USB-C type cable? Nothing. You can connect with each other, but that's all. You actually need an adapter to charge your phone or your laptops to work with it. So simply, in this reference format, APIs are just your adapters and MCP is your USB-C type cable. Existing, whether you're using gRPCs, REST APIs, GraphQL database, or any other Kubernetes APIs or API gateway cloud SDKs, those will remain same. You'll just add a layer on top of it, which will allow your functioning to be much more smoother. Yeah.
Yeah, that is one of the searched question around, if we already have the API, then why we need the MCP? And you explained it so well. And just to fill something, people maybe question around what exactly the point where they should decide this is the time I really need to understand I need MCP server. Because
Hmm.
if we start building the MCP server with the premature, that's again a problem, because we trying to solve a problem that does not exist yet, or
Yes.
maybe we have so much complicated system that it seems like hard how we can make the MCP server functional. So what's your prospect on this?
On when MCP server comes into the play, I would say when your use case is not just defined to a single feature.
Yeah.
Um, because if it is just defined to a single feature or a simple integration with either of a platform,
Mhm.
or even on your own platform, the product that you have, it comes into it. And uh, taking an example of Argo CD, or yeah, let's take an example of Argo CD or Jenkins. Those are popular tools for your GitOps purposes, right? And that's all they are. I don't need a Jenkins MCP server to tell me, okay, what I have deployed. I can see that it's an inbuilt capability. Rather, I would just have a simple AI summarizer. But at the same place, in my platform, I have more capabilities. For example, GitHub, which takes your GitHub action, do the Docker registry, release version management, or harness, who does those things. Then I would need an MCP server, because here I just do not want to check for my pipeline status or my deployment status. Based on those, I want to take actions as well. And that's it. If your feature requires you to work across the board and take some decisive actions on your behalf, then only the MCP server should come into the play.
Amazing. Yeah, right. I absolutely agree with that. Uh, Thanks a lot, Animesh. Just to simplify around the MCP, I believe this is the important conversation most developer really need to be, understand and do the interaction around it. And I will not make more waiting. So let's move into the presentation and understand the architecture visually in depth. Can you help us?
Sure. Let me share my screen. Let me know if it's visible.
Now it's visible.
Okay, got it. Hi everyone. So in a very short, we'll try to cover what previous model was, why it worked for those time, and why the decision have been made to move towards streamable HTTP. Previously, also HTTP was there; it's still there. So, what have changed, and why it affect us? So, Rajan already gave my great introduction, so I'll be skipping this. Moving to how I came across this. So, early in 2025, when the MCP protocols were released and was more on a hyper front, um, I was also exploring the MCP and setting up my servers, connected with Claude desktop, which was working fine till everything was on local. So I wanted to see on how it would work on a production and do a product and launch. Uh, However, after deploying it behind the load balancer, right, I noticed 60 to 50% of my request was silently feeling through, which was not the case when I was testing it or my friends were helping me to test it locally. And after a very painful duration of debugging it, we got to know that both SSE connections and the post call, which is an HTTP call, needed to be processed by the same server instance as the response. Now, this may not feel very this may not feel very like very silly for people who have been doing this, but it was very new for me. This was a story of around March 2025, when the MCPs when I tried this. Half of the SDK versions are out there still told that okay, what I'm doing is fine because I was using an npm package, and this is how that they have explained. But silently, in that specific month, a new package was released which moved everything from this dual endpoint architecture to a single one. I wasn't not aware of this, and I even didn't knew that there is an another architecture. So that's why this was very important, because SSE wasn't deprecated, which was a hype during that time, and that is a conversation which is still in a debate till today. The format itself is alive. It was a dual endpoint architecture that was deprecated, so that you don't need sticky sessions or maintain two transport layer or a protocol methods just to get your MCP servers online working with them. Now it has moved to the single endpoint architecture. Both the guest and get endpoints with the SEC enabled inbuilt can work or serve at the single route, right? And it can be JSON, it can be an event stream, anything that you want it to be. Later we'll see on how this impacts, and if there are changes that you need to make, how you can do so. So this is what an SSE response actually looks like when we talk about an MCP server, right? So you have your stream that gives you in a JSON format what the specs are. The payload comes in, right? Then you get the event IDs, you get retries. This is still the method which is still alive. So throughout the journey, this is the only thing that have survived, whether it's in a previous architecture or the current architecture. Now, this was a major decision, but why? Um, because from a developer's perspective, at that time, it made much more sense to make things stable rather than operational scalable. So this is a very frequent term that or a code that I have heard. We should ship faster and then later optimize for the performance, because if we are waiting for the performance and not able to ship, we are already behind, the feature doesn't work, and there is another problem gap which exists right now. So previously, the architecture was made very simple for us to either use it, modify it based on that duration. So we had one get SSE, which used to open the persistent connection, uh, which used to serve our URL used to serve on those stream events. Client, we had then had a post uh, endpoint which we were using as a conversation, which used to send our message request through that persistent connection and then get the response back in the same stream. So the only problem was both of them had to serve at the single instance. If by chance, if by chance, um, my get request went to a pod one, so according to the server and a client, that is where my session lives. It's one where the open connection is available. But maybe due to the load balancing that was in effect, my post messages went to the pod 2. Now pod 2 have no idea because it doesn't have the session, it doesn't know the context, it just got a response request whose answer it does not have. So it used to throw 404, right? And this was the sticky session problem that many of us faced, and for that we had to do a lot of work around. So this new architecture actually solves those problems, because most of the times, even when we are optimizing for the models or the agents that we have built with the MCP, we generally tend to put it behind our load balancers so that we know in case anything goes down, everything is working fine. If one instance is down, there is another two which is working and balancing our distributing our sessions or traffic around it. So now we do not require sticky sessions anymore because load balancers, um, sorry, my bad. Most of the sticky sessions do not do this like in a previous architecture, because load balancers were never trained to be stateless or work with the serverless very efficiently, right? So the sticky sessions weren't valid on those if you're working in those sense. And as I said, if the pod 1 connection, the persistent connection drops, then the whole process has to be started again. So later, previously in the last year, we would have seen a lot of times that if you're talking, we would get the network interruption or the connection, please try again later, or a try again better, whether we are working with a Grok or GPT or a Claude, right? So those were the reasons for it. Now, auth complexity was another one, because how we authenticate our event stream session is very different from how we authenticate our normal HTTP protocols. And serverless, as I mentioned, load balancers do not handle sticky sessions very well by default. We had to do a lot of work around. And in case of serverless, there was just no way. So to tackle those problems, a new architecture was released in March 2025. It was a very slow spec release. So now how it happens, a single endpoint have been defined. Most of the companies also use this, that's slash MCP, where your both the SSE or stream event streams plus the text streams lives now. By default, it's stateless. Now you can have a sticky session. That's an optional. There is workaround for now it to work, uh, which might be going away soon and becoming stateless by default only. Uh, so now there is no handshake required. How previously we had to first establish an open connection through the event stream to the same connection, get the response back, right? The initial handshake is no longer required. Everything happens in a same connection. So it's just like to and fro. You share the request, you get the response ASAP. And since everything is defined under a single route, authentications are no longer a problem. You just have a standard authentication bearer and it works. Plus, since the sticky sessions aren't required anymore to have the conversation with your MCP server, it works even across the standard LBs without any workaround. Plus, you can also go serverless with this one. So this was the old endpoint pattern. You can see we have one get and one message stream, one get, one post for both different SSEs and the normal text messages that we want to send. This is the new one. You define a single post MCP endpoint, right? And in the logic, you just have a place depending on the type of the request, right? Those will be handled. So, for example, the handle request in this one decides the response mode per request, where the SSE format is still alive. It's not dead. You didn't lose anything by migrating, or even if you try to shift it right now. How it happens? If so, how this happens? If during this one, I opt in to handle request to pick maybe a event stream, right, which is a default case. It will pick a JSON. It will give the response back, or SSE response per request, however it goes. In case I want to have a text responses, it will check what type of request I want to raise, and based on then it will again pick our normal HTTP one. So this is a benefit of the dual endpoint, single endpoint with dual benefits, more like a unified thing. You let your server handle based on the request that you want to share or you want to get it down. So this is the Go stateless default, and this is a candidate release as well for the July 28, 2026, which is happening this month, just a week and couple of week after. And why this is important? Because this approach utilizes streamable HTTP pattern that we discussed, a single endpoint pattern. And regardless of which pod you share or the whichever pod gets the request, every request is self-contained, right? So the server doesn't need to hold any TCP connection or between the request, maintain those connections. As soon as the request comes in, whichever load balancer or whichever pod is available, it will handle it, no matter how the traffic is distributed. So, and just in case, as I mentioned earlier, if you do need stateful sessions, Streamable HTTP supports those two as well via MCP session ID header, but it's opt-in. You can choose it if you want. Otherwise, they have much more that have come up with the MCP name, MCP body, and more headers, which is now a new default. And even if you do or go for stateful streamable HTTP, you can use external sessions or those stored in Redis, Valkey, rather than in process memory, right? So you are no longer required to stick just by pods, have each configuration by pod. You just have to make changes on a higher architecture level. But we can't have a migration without our checklist in place, right? So if you're using SDK versions specifically for npm have split into two different packages that you have to make sure that you are on the right versions. If you're using Python, they have evolved. It's a single Python library, easy to use. If you have a dual endpoint architecture in system, try to maintain the backward compatibility till you no longer need it, because there could be a migration delay and you do not want your old users or old architecture to die down suddenly. Auth header forwarding is something that was previously done in a query parameter, but now it needs to be in a standardization authorization behavior tokens that we have. And session cleanup leaks. This is very important because if you use session maps, you need an eviction strategy as well, whether it's an in-memory state or horizontal scaling, right? Because if you do not handle this, then your previous state will lose. So once these things are in mind, you can choose your own transport on how you want to do work. So right now, for local developments, it's still stdio, but for more remote or production ready MCP servers, it would be streamable HTTP. If you just want to use it at a local, go ahead, use stdio. It's the best one, faster to test, debug, and everything. If you need a real time response from live, streamable HTTP works well when you have deployed. Do you need a session state requirement? No, you already have your streamable HTTP. If you need yes, then again, as we talked about earlier, you would need additional Redis or Valkey for the extension storage, extensive storage DB, and then you can use with the sessions with the streamable HTTP. And this is in a hypothetical. These a lot of company have started the deprecation. So Kebola had April 1 as its deadline. Atlassian's Rovo had June 30th. They have already asking their customers to move or start using /MCP rather than old structure. And more vendors throughout the 2026 are following this pattern. With the candidate release finally coming live, there is a month, like a year, there's 1 year as a buffer given additional, so that every client, every user, or every developer can eventually migrate to like the streamable HTTP format before their clients or deprecation notice gets it. Now, Um, the case in migration, how Atlassians did it, right? They released it in May itself. That we are going, that it's official. June 30th is the last for using the old architecture diagram. They moved from slash v1 slash sse to v1 slash mcp, and the deadline was only for the backward compatibility. Since we are in July now, uh, the whole customer base have started using to mcp, whether we are using Jira tickets or Confluence or Rovo, any internal that is provided by Atlassians, even the Bitbucket, have eventually moved to the MCP server. So we got HTTP, right? We have SSE within the HTTP now. So what about WebSockets and gRPC? Those are the protocols as well. So there are issues and there are PRs which are already in MCP to add the support for gRPC and WebSockets. However, till now, there is only two official transport that remains: STDO for local and Streamable HTTP, which have gone live. The reason WebSocket was not supported yet, because it requires a lot more conversation around the architecture and the future which is related to MCP. But the PRs of both the gRPC and WebSockets are in there into their GitHub discussion as well. So for a trial out, or if someone wants to pick it up, have more larger discussion where the future of MCP is going on, they can pick it up. Even if you want to try it out, it's generally expected that you try it out locally on your own with the code bases that you have. So the only reason um, these are not there is because of how the future or the maintainers have decided to evolve the MCP protocol for the future, moving towards the stateless. And with the WebSockets and the gRPC, uh, maybe we would reach there one day. But for now, it is still one of the proposals that is highly debatable. So on the next Monday morning, remember what have actually changed. Check your SDK versions if you're dependent on any of the libraries which have already deprecated. It's time to start upgrading your packages and slowly migrating towards the more stateless driven architecture, and add a compaction. Check whether the clear legacies you have let your users know if you are exposing it to your customers, or an internal developer guide, so that they know that SSE requests are no longer valid, and it doesn't just get silently failed on 404. Have that the new, this is the new path, use this one. So let's dive into the demo. For example, I've created a skill called author db change, which, and I have asked it to add last check timestamp column to my product table in my DB DevOps harness schema and my default org and such. So you can see the Claude launched the skill. It start by confirming whether the skill exists using the MCP server. So it made calls such as get harness resources, list harness resources. So once it was able to confirm the type of my instance, my schema, it created a change log based on my proposal, right? Once it was done, it asked me whether I want to apply the changes, yes, no, or should it edit. So this combination gives me a certain advantage that I can check, okay, what are the things that I'm going to deploy into my schema and how they are going to work. So once I have approved the changes, it triggered the pipeline. It look, okay, this is the specific pipeline that gets triggered, and this was the DB instance ID. It filled in all the data that it required by working in the correlation with the MCP server, so that each input is as it is supposed to be provided. Why this is unique? Because in my pipeline, I can't pass my YAML file as it is. It needs to be converted to the base 64 before it is passed to the harness MCP server. So skill understood that the input it requires is not what is about to be passed. So it prompted me to change and convert it to the base 64. Once I approved those changes, it then triggered the and executed the pipeline. And using the servers MCP server tools which it has internally, It gave me a pipeline description properly, like what the chain sets are, what is the verification, what is the repo type, username if I have anything else, directly within my Claude desktop window. And as you can see on my pipeline, I can actually see it was triggered, and the name is by me, but it was not manual. It was through the MCP and the skills orchestration. So I can see, okay, everything is passing successfully. The merge chain set worked fine. Now it's validating the database whether the changes applied make sense or not. Once it was done, the plugin was validated, like the command was validated, the changes were validated. Then the DB schema update took place. My SQLs were updated, and those were then pushed to my Git repository. So this is a powerful combination that we have to keep in mind. There are certain tasks that only skills can perform. There are certain tasks only the skills can perform in addition or with the help of MCP servers. And the prompt is what I provide to it to fulfill my requirement. So we can see, okay, these are the files, previews, chain sets, and the same thing that I did earlier. Now I can review it in within the PR what changed. So I built this way because I wanted to be in a middleman as a manual approval before anything goes to the production. And as we can see in the skill, it determined that the inputs that I already have, right, the environment variables and such, which is already in the pipeline. Based on that, it executed the specific pipeline and rest ignored it, and resulted back what were the changes, what was the complete status, and what is newly added. And that's all.
Thanks a lot, Animesh, just to explain in so depth. So, what I am thinking right now is how the MCP is evolving like so fast, and we start moving in so depth about how MCPs started and then how MCPs evolved, and now the challenges we have with the MCP, and now in the next phase is coming, what we need to
Yes.
do. So
Yes.
yeah, that's a lot. So let me do one thing. Let me do a quick summarize what I understand.
Yep.
So what I understand from the presentation before we move into a deeper discussion is SSE itself has no has not disappeared. It is
Yes.
still
It's
used when an MCP server need to stream responses or maybe the notifications. That's my understanding. The major change was the older two endpoint architecture where one endpoint maintained the SCC connection and another endpoint received messages from the client. And
yes.
the streamable HTTP brings communication between under a unified MCP endpoint and allow the server
Yes.
to return either a regular JSON response or the SSE stream. Depends on the request,
Yes.
of course.
Yes. Yes.
This makes remote MCP server easy to deploy and operate. That's my understanding, but it does not automatically solve every production challenges.
Yes, it is just there to like give more freedom of I would say experimenting to the developers and the customers, more on a developer front, because maintaining two different architecture,
Yeah.
uh, like in a previous architecture we have to maintain two different endpoints, making sure that they are in sync, making sure that your request does not fall, had a lot of workarounds which were not um, um, either supported by default, or um, it used to take a lot of bandwidth out of engineering and workarounds, which eventually do a increase in cost as well,
Yeah.
because you can't, even if with the load balancer, if there's 1,000 pods, that's going to increase your cost. And if the model starts hitting more, each time it retries, those again comes into the picture.
Yes.
So with the new architecture, the problem solved have decreased for us as a developer or us as a company to now have everything in one place, maintain the single thing which works in a better manner. It's how previously we can treat MCP protocols as a teenager,
Yes.
right?
Yes.
Uh, they do a lot of different things to try it out, playing, fighting, and a lot. But now it have evolved into more on a adult phase or a post-teen phase. It's about to hit 18 age,
Yeah,
where it have got a better idea on what it wants to do and how it wants to do.
that's absolute definition. And still, teams still need to make careful decision about
Yes.
session state, maybe the load balancing. If we have the Aminesh Pathak explained, horizontal scaling, authentication, reconnection, retries, security, observability. I mean, tons of the things. You have to be very careful. As Animesh already explained, the teenage now moving to become an adult who have more responsibilities. So you need to understand the bridge between that. With that understanding, let us go a little bit deeper into what this change means in real production environments. So, what exactly did Streamable HTTP solve compared with older HTTP plus SSE architecture? And what are developers still misunderstood about when they say the SSE has been depreciated? I know, I mean, we already talk about it, but still
Yes.
asking that particular question to give a limelight on that particular how the SSE has been depreciated.
Definitely, and I think this misconception will be there for a while,
Yeah.
till it's like till it becomes more available with everyone, right? That SSE was deprecated. This is not true, and I don't think SSE is going to go anywhere till we get something new which can replace SSE. Uh, Streamable HTTP uses even stream plus text.
Hmm.
Uh, Whenever the server wants the stream response, they get the stream response. Whenever they want the text response, they can handle the text response. The only thing that was deprecated was the architecture, the remote transport architecture, which used to have two endpoints, HTTP plus SSE, both had to maintain itself. And the new architecture replaced both of them with a single post request, which can return again JSON response or even stream depending on the request. So a developer should not think, since SEC is missing from this protocol name, it's deprecated. It was never about SSE versus HTTP, right? It was more about the old architecture and the new architecture.
I
The SSE or the event streams now just lives under the HTTP architecture, which makes it
it is.
again the streamable.
Yeah.
Otherwise,
Yeah.
how can we make HTTP streamable?
Right, that's a goal. And as you already explained about the streamable HTTP completely, one of the hardwire with the sticky session is a problem with the developer that freak them out about, oh, there's a problem with this sticky session nowadays. So let me simplify the question. Does streamable HTTP completely remove the need of sticky session, or does that depends on whether the MCP server is stateless or the session based? And how should session be handled when the server runs across multiple Kubernetes pods or the cloud?
Got it. So yes, the answer is it depends.
Okay.
If your MCP server is completely stateless, then yes,
Mhm.
you do not need it. Any request can land on any pod, and that's the ideal deployment model,
Mhm.
which is the current one. But if your MCP servers generally need that the conventional state, let's have it, whether it's a long running pods
Mhm.
or human approvals or multi-step execution. For example, if I have five different stages each having those things, right, then obviously we would still need sticky sessions for to support us across these panel, right? In those situations, you still need to store your sessions state somewhere. Either we can have, in the current model, we can have it stored in our Redis or a Valkey, or we can have an in-process memory, but which would again make it more hard if it's an in-process memory,
Yes,
right?
that's right.
So even if we are talking about across 1,000 pods, the difference is that you are no longer forced to keep it inside one single pod or one single process or one single connection. You can move it to it any distributed cache, or another. You can maybe even have another shared storage layer on top of your pods, so that it lives outside. You can use again the Redis, Valky, and such, which becomes much more healthier architecture than to just rely on the sticky
Yep.
sessions at the load balancer
Yes,
level.
yes. I absolutely agree with that. And one of the state which I think is going to afraid more around the migrations, because like you explain a lot, and the scenarios is like, okay, MCP released a solution where it's done with the migration. Migration is sometimes presented as a simple replacing the old transport class and changing the endpoint, but in a real production environment, let me ask this particular question is, what additional changes should team expect around SDK compatibility, the older clients, authentication, proxies, or especially the load balancer and the session management?
Got it. Let me take it one by one. Compared to the new changes that we have, there is definitely better scalability,
Yes.
since you do not need to configure load balancers anymore just to handle the sticky sessions.
Yeah.
You can deploy it behind any standard load balancers that we get,
Mhm.
right? uh, Reliability also improves because we are not about to be affected with the whole handshake calls anymore. Each request are self-contained. Each request have both the required request parameters
Mhm.
inputs, which is very self-sufficient, right? um, Plus the deployment complexity also decreases, as in the previous I explained. If you need to be 100% stateless, right, you do not need a session storage and anything like that.
Yeah.
So you can just enable your how you enable your Kubernetes cluster. You can just put it at auto scaling. Keep it simple, easier, similar to how you deploy your Kubernetes. Now coming to the deprecation or the migration from the application level, uh, there are few like touch to go things,
Mhm.
right? The popularly, yeah, definitely most popular to like packages or the languages in which the MCP is written nowadays is either a TypeScript one or a Python based, right? The Python SDK got updated. It went to I think MCP 2.0 version something, which is again a candidate release. And how would it work? Uh, it has upcoming protocol changes within it. So previously, when we used to update our packages dependencies, we sometimes tend to blindly update our packages, right? But if this happens in the case of whether a Python, if you update it to MCP 2 point slash something, your current architecture would break because it does not or do not no longer support the old one. It have a new protocol in places already. If I talk about TypeScript one again, we can't update it because the newer package, the current package, have been split into two.
Mhm.
So we need both of them. One is I think version, second is the client base. So uh, projects which are migrating to the new architecture will need to update their dependencies as well and the imports, and making sure before they update it or before they release it to the production, they have done the necessary migrations on their transport layer itself,
Yeah.
right? On the proxies, if you are working with the kube proxies or a ebpf based proxy, nothing for you would change, because in the terms of the interaction, uh, that haven't changed a bit. It's how we previously used to have and would remain in same in the future as well.
That's
Yeah.
that's great. Yeah, I mean the proxy is the one thing which I really people make it take it lightly, but the proxy is something you are gonna use a lot in the productions. Yes.
On proxies, I think only one thing you need to experiment with is if there you are doing a reverse proxies,
Mm-hmm.
right? Because from your application going through something between the proxy and then landing the conversation or providing the request response, if you had the sticky sessions, right, then there would be a buffering sometime because it needs to have a context and such, and some gateways have those aggressive timeout. um, you need to check with your whatever ingress controller handles you use, or API gateways or agent gateways that you use, that they do support streaming connections now. Most of them do. um, so there won't be any change, but if you have fixed it for the sticky sessions itself,
Yes.
then you need to update those as well.
So, like, just you explained about this streaming connection drops.
Mhm. Mhm.
While a long running MCP tool is still executing,
Yes.
uh, and what happened when a streaming connection drops, right? If we have the long running MCP tool still running, and how can team safely manage reconnection because and retries without accidentally running the same deployment, database change, or any external operation twice?
So that's actually a really great question because it becomes extremely important
Yes.
for enterprise workloads when we talk about them, right? Because they are the ones who will be using this. Imagine your MCP tool is deploying a Kubernetes, maybe applying your rollout migrations as well to different clusters, different pods, and also helping you with providing cloud resources or provisioning them, sending payments, transactions, and such. So if the client retries blindly after a initial disconnect, there's a chance that you could be executing the same operation twice,
Yes.
which is very disruptive, right? And the transport layer shouldn't be responsible for preventing your duplicate business operations, whether it's a transaction, payment, or again creation of any resources. On those fronts, the design would change a bit, right? Applications by default should be idempotent wherever possible. Use the request identifier. Try to have a persistent execution state. Resume the work instead of restarting it. So just in case the connection have dropped, rather than establishing a new one or starting the whole operation once again, just check if it's possible to connect with one another,
Yeah.
right? Because the protocol generally provides the both the protocols have mechanism for session management and recovery,
Yes.
but the application level safety would still belong to the whoever and however you are implementing your own tool with it.
Yes.
So just in case you do not want to pay for same thing twice, you do not want a same resources to be created twice, so that will be up to you.
Great. And I really have a question which one I feel like is important. And my last question. So, based on your experience with the harness or the real MCP implementation,
Mhm.
what should team test and monitor before declaring, hey, an MCP server production ready for multiple users or the multiple
It's
or the
life for
real
yeah, go ahead.
enterprise traffic? Yes.
Um, do not treat it as your local hobby project.
Yeah.
So we should treat MCP server exactly how we treat our backend services. Before, even after it goes into the production life cycle, we test it at different stages, whether it's a dev environment, staging environment, pre-production environment, before actually hitting the production slowly.
Yes.
So after the local testing, because it would work, I think STDO transport, whoever made it,
Mhm.
have made it so in a such a way that it's never going to fail at local testing.
Yes.
But the things would break when we are trying it in the pre-production staging or dev environment.
Yeah.
So instead of verifying multiple like a single user, verify with the multiple concurrent users. So you me testing same thing at the same time, how it's working
Mhm.
across maybe multiple Kubernetes services that we have. You're testing in prod 1 cluster, prod 2 cluster, prod 3 cluster, rolling out the deployments gradually to check whether okay it's working fine or not before making an announcement, checking behind the load balancer routing if it's working fine or not, authentication expiration, what is the state date. I have seen a case where I have seen a case. I have done this on my own as well. By chance, I let the authentication expire until 11 days when it was supposed to be just 2 days,
Mm.
right? So, this would, if the authentication of this feature or bug, as we call it in the dev environment, would have gone live.
Yeah.
Anyone who is using it would be able to use it for the persistent 11 days, which is again very bad. How it handles the network interruption, tried with different network testing or network load testing, as we say. How is it the streaming behavior, does it buffer, or if there is something which you can optimize for. How we handle the retries rather than restarting the process again post the everything is done, how the session cleanups happen.
Mhm.
If something is breaking, do I have an observability where and why it broke? Do I get the logs, or is my Prometheus, Grafana, or Hotel let me know, okay, this is the reason why it might have broken,
Yeah.
right? And I would also recommend you to like deliberately try to break it during the testing, because then it would you would have a better idea on what you did and why and what manner it would have been broken. Because if your server is only working when there is a small amount of traffic, it's okay. But if you have this is not a general case with enterprise workload, right? At the same time, the traffic cannot be pinned only to a smaller cluster or maybe a single pod. You need a lot more.
Yes.
So if your final architecture is not able to solve it or throw certain errors, then you should, before the production ready, like announcing it's production ready, you have to do a bit of cleanup, revamp again. So the goal should be like to build a server that behaves precisely,
Yes.
do a proper chaos testing, anything, not just in a works on my machine statement.
I absolutely agree with that. And one thing, like just you said, if it is failing, then I would say that fail it fast so you understand it well,
Yes,
how exactly you can understand that instead of failing in the prediction. So
right.
extensive testing is going to stay here as long as we are here, and the testing is the only way that can identify or give the trust around the system. So yes, Animesh, thank you for helping us understand that this change is not simply about uh, replacing SSE with another technology.
Yes.
You help us understand the architectural problem behind the older, I would say, dual endpoint approach, why it's become difficult behind load balancer, and how streamable HTTP provides a clear foundation for the remote MCP servers. At the same time, the conversation also showed that a unified endpoint does not eliminate the need for a good engineering. Teams
Yes.
still need to think carefully about state, session, routing, and the authentication, retries, security, like Animesh explained, observability is very important, and the multi-user isolation. So thank you for joining us and sharing your experience. Thanks a lot, Animesh.
Thank you for having me. And I would just say, as AI system have moved into enterprise environment, and I am pretty sure that it's going to evolve at more faster ways. The architecture details become just as important as like what prompts we are using, what tools we are using, and what models are yet supported.
Yeah.
Because without any right combination, we might not get our desired results
Yes.
on this.
Yes. I agree. I agree. Thanks a lot, Animesh, for that. So, for today's conversation, what is the takeaways? I think the final point connects directly with the purpose of this podcast. Building an MCP server that responds correctly on a local machine, it's an important first step. But production readiness required testing the conditions that do not normally appear during a local demo. Test teams need to understand what happens when requests reach different replicas, and they need to know what happens when a session expires, a stream disconnect, a client retries a request, or multiple users involve tools at the same time. They also need visibility into the failed request, active sessions, uh, tool execution time, authentication failures, reconnection attempts, and unexpected uh, legacy client traffic. A system is not production ready simply because the normal request path works. It becomes production ready when the team understand and test how it behaved during failure, scaling, concurrency, and the recovery. An MCP server working locally proves that the tool can function. It does not automatically prove that the server is ready for the multiple users, multiple replicas, load balancers, or the network failure, enterprise traffic. Then journey from a working demo to a repeatable production system is exactly what we explore through this podcast. And thank you everyone watching or listening this episode. Thank you for joining us. We will see you in the next episode of Demo to Production.